In software development, we are taught to separate our concerns. To explain what that implies, I need to take an example. Let's imagine you have my go-to example, but it doesn't really matter. The problem is similar in all pieces of code. But let's imagine you have an HTTP endpoint that is supposed to update data in a database table. Okay? So now you have an HTTP controller, you have a view model, you have an entity, an ORM library for .NET Core. That would typically be entity framework. You you're using the data repository pattern, maybe. So you end up with some data wrapper code to encapsulate and hide the data layer of your application. Maybe you want to completely further separate your concerns by creating a service class that touches your data layer. So you end up with the service implementation and an interface. Now you have to configure your ORM library maybe and your service class. Then you have to create a mapper configuration code from your view model to your database model. Maybe your code is reading configuration settings, at which point you need a configuration wrapper. So now you got 25 files where you need to edit like 5 files or something to apply a single tiny little change. And because of your complexity now, the complexity of your code, you are forced to create unit tests for it to verify that it's working as it is supposed to be working, as you are later applying changes. Because you have unit tests now, you want to create a pipeline that automatically triggers upon push towards the upstream Git repository. Because you have unit tests and automated pipelines, you now probably might want to create some sort of like static analysis of your code base upon commits to the upstream to verify that you have enough unit test coverage and that you don't add too much cognitive complexity in any parts of your code, etc., etc. Because you now have all that infrastructure, you might want to add a policy such that every single time something is pushed towards the upstream, you need 2 additional software developers to accept your pull request, etc., etc., etc. Now, some people here at this point will accuse me of mixing up different subjects and concepts. But actually it all originates from your need to separate your concerns. That's where the entirety of the problem originates. So I now have 25 files. I have a process that implies 3 developers requiring to look at my freaking code before it's deployed to my development environment. I have a development environment. I have multiple, different environments. I have a complexity that basically is 100 times higher than what is required to actually create the application or the endpoint in the first place. Now, with that in mind, let me show you how I would solve the task I started out with. Remember, I wanted to create an HTTP endpoint that updates database records.
So here I am inside of a Cloud Rat. Let's create an HTTP endpoint that updates database records. So let's have a look at the SQL Studio and use our Chinook database as our source database. So here we have, let's create an endpoint for album, okay? So now I'm going to manually create the code, but I wouldn't have to. I could automatically generate it, of course. But for the purpose of this exercise, I'm just going to create a new folder, call it test3. And then I'm going to create a new hyperlambda file. I'm going to call it album.put.hl. For updating records, you'd typically want to use put. So updates a record of type album, right? So now what arguments do we want to possibly pass in? We definitely want album ID, right? Album ID. And album ID is of type integer. Okay, let's do int. We definitely want to do, we might want to do a title. Okay, title. Title is of type string. And then we might optionally also want to update the artist ID. Artist ID. An artist ID can is an integer. So now we have passed in all three arguments: album ID, title, and artist ID. Album ID, title, and artist ID. At this point, we want to open up a database connection, data.connect Chinook. Now inside of this database connection, we want to do data.update. And then the table name is album. Then we have a where statement because we do not want to allow for updating more than one record. So we would add an and statement here and write album id.eq arguments album ID. And then we want to have the album ID as a mandatory column. Mandatory. Save it for now, and then we want to pass in all columns except album ID into values here. Add data.update values. Get nodes arguments 1.5. Doesn't matter, it doesn't go off bounds anyways. So now we're basically passing in every single argument given, starting from argument 1 to potentially 5 arguments into its value collection. And then we want to do status 201, return, result, success, save it. So now let's go back into SQL Studio. Let's find, select all from album and find some record. Okay, for those about to rock, album ID 1. Okay, let's change it to, you know, album ID 1, QWERTY, right? Let's have a look at it now, and I'm done. Let's change its artist ID just for kicks. 1, XXX, and 2. And now the artist ID should be 2. Let's just reset it back to what it was. And I'm basically done.
If I was to follow best practices using OOP, what I just did now in 20 seconds would take me 3 days. And the reasons for that is what I refer to as astronaut architecture, where we would end up with an overly complex separation of concerns, where we would create our code way too modular, where we'd end up having a service implementation, a controller, a view model, a database model using ORM libraries, etc., etc. And at the end of the day, we'd achieve literally nothing. The only thing the separation of concerns actually gives us is more complex code. It doesn't really give us anything besides that. And it also complicates our process, because now, due to this complexity, we can no longer work fast, because now we need, Git pipelines and, automated unit tests and God knows what more.
I want to emphasize, just because I have significantly reduced my separation of concerns in this code, I can still use constructs from functional programming to make sure that my code is easily readable, has good encapsulation, and a high degree of cohesion. Now, to illustrate that, I'm going to create a folder inside of my test3 folder here. I'm going to call it magic.startup. Then inside of this folder, I'm going to create something called integrate with whatever, right? .hl. Then I'm going to copy this guy, and then just click the guy and write slots create, and then log.info. Object was updated. Object album was updated. Album ID. Arguments. Album ID. Then I'm going to save this guy, execute it, and then I am going to show an example of how let's say I had some sort of like a complex integration, right? That would trigger an HTTP invocation, resulting in code that was 30 additional lines of code. Maybe I wanted to reuse that code in multiple endpoints, etc., etc. Now I can execute that as a function, pass in album ID, arguments, album ID. I can save this code. Now when I execute my code, album ID 1, updated. Then the point being, now, if I go into my log here now, then I will see a log entry. Now, of course, the code I created in this particular example was way too simple for me to be wanting to put it into a separate file, but I wanted to illustrate that you can still create functions where you encapsulate additional complexity that allows you to reuse codes and reduce the size of your code to a point where it is still readable. But that is not separation of concern. That is just sane software development.